So we are going to continue the previous subnetting concept which we did in the part 1, where we have seen some basic examples of subnetting. So we'll move to the same continuation for our subnetting. Probably we'll try to revise once again the same calculations, and then we'll move on with the next requirement. Like we have seen the last example, we have taken the requirement of 40 hosts with a C class network. So we are using the formula called 2 to the power of h minus 2 greater than or equal to requirement. Based on this formula, we are going to take 2 power value. So whichever 2 power value satisfies near to 40, means if I take 2 to the power of 532. So let me just move on with one example here. Before we move on, we did one example. So I'll take one more example of C class before we continue with B class and A class further examples. So let's start with the first question here. Let's take an example. We are going to do an example of FLSM, fixed length subnet mask, and where the question is, the requirement is, let's say 12 hosts. So I gave some examples in the previous video to practice. So once you do some enough practice with those examples, anyway, I'll just quickly revise this example using any C class address. Any C class, the calculation remains the same. So I'm going to start with this. If you remember, whenever you are doing the calculation as per the host requirement, we have to take the formula as 2 to the power of h minus 2 greater than or equal to requirement. So in our case, the requirement is just 12 hosts, and I'm going to use any C class example, and that C class example supports by default 256 addresses in one network. So I don't need 256. I want to divide that C class network into small subnetworks, where each and every subnetwork should be minimum of 12 hosts, at least 12. Anything more than 12, it's okay. So we are going to take 2 to the power of minus 2. So power value we need to consider any power value which satisfy the condition. So if you try to verify the power table, so if I take 2 to the power of 3, it's not going to satisfy my condition because my requirement is 12 hosts. So I need to go with 2 to the power of 416, means exact 12 hosts you cannot divide. The only possible size nearest to 12 is 16. So I'm going to take 2 to the power of 4 here as per my requirement, as per my question, 2 to the power of 4. So now 2 to the power of 4 becomes 16. In the two addresses, we cannot use the first and the last address. So out of 16 addresses, 2 addresses we cannot use. So total 14 is your valid host addresses. Means in case if you want to extend number of devices in that particular requirement, we can maximum go with 14 devices. Even though we get 16 addresses, 2 we have to subtract, that is for network ID and the broadcast ID. Okay, so let us move on with continuation here. So from this, we need to understand how many host bits. So second step is just figuring out how many host bits, whatever the power value you are taking, that is your host bits. So whatever I took here, the same host bits, that is considered as the required host bits. So I'm not writing required host bits, just we consider it as a h value represents host bits. So now converted bits. So as we already know that in the subnetting, we need to convert the number of bits depending upon the requirement. So I'm going to use a C class example. In C class example, by default, there are 3 network portions. As you remember, it is 255, 255, 255, 255, 255, 255, and one host portion. So if I write that 255 in binary format, 1, 2, 3, 4, 5, 6, 7, 8, 8 bits in the first portion, 8 bits in the second portion. I think 1, 2, 3, 4, 5, 6, 7, 8. Okay. So okay, I got one extra, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So similar way, 1, 2, 3, 4, 5, 6, 7, 8, the third portion, and the fourth portion is just having 8 host bits. So 1, 2, 3, 4, 5, 6, 7, 8. So once you are much comfortable with the subnetting calculations, we really don't need to write down each and every step. But here I'm just writing so that we can have a very good understanding on a step-by-step calculation, how it goes. Okay. So 8 host bits. So out of 8 host bits, I don't need 8 as per my requirement. We can see here as per my requirement here. If I just take 4 as a host bits, that is more than enough. So it's enough for me. So I'm going to use only 4 host bits. So h value will be 4. Whereas remaining 4, I'm going to convert them into ones, that is networks. So total becomes, or we can do like this also. Converted network bits, that is nothing but small n value, is equal to total host bits. Total there are 8 host bits. So out of total 8 host bits, I'm going to subtract the required host bits. So required host bits are just 4. So I'm going to subtract that 4. The 4 value I got it from here. So 4 gets converted. Either you do like this or like this, both are same. Both are actually the same methods. So now finally total network bits. So if I just say total n bits, nothing but total network bits is equal to, by default there are 24, and I'm going to add 4 extra, so it becomes 28. Just make it as /28. By the end of this video and session, probably will understand more in detail what is that slash value and what exactly it represents. So as of now, slash value, just make it as slash value here. So total network bits is equal to, there are 8 bits by default, 8 by default, 8 by default. So by default we have 3 host network portions, 24 default plus 4 extra added. So it becomes total bits is equal to /28. So now after doing subnetting, the tally of default 1616, sorry, I'm going to use C class. So when I'm using C class, by default there are 24 network bits and 8 host bits. So tally of 24 8 has been changed to 28 and 4, which means 28 network bits and 4 host bits. So there are 28 network bits. You can see here 8 8 8 24 24 plus 4, 28 network bits and 4 host bits. So this understanding this bits conversion is very important, because all the calculations, all the subnetting methods follow based on this number of bits. So you should have very clear idea on how many host bits we require, how many we need to convert, and how many becomes total, and finally how many network bits and how many host bits after doing subnetting. And then based on that we can even calculate the size of the network. So anyway, we'll come to that size. So before that, let us finish off 2 more steps. Subnet mask. So if I want to write my subnet mask, this is my subnet mask. Whatever you see here, this is your subnet mask. It is in binary format, so we are going to write in decimal format. So if I add 8 bits, 255. If I add 8 bits, 255. If I add 8 bits, 255. And if I add 4 bits, that is 128 plus 64 plus 32 plus 16, binary to decimal conversions, I get 240. So probably you don't really need to much remember these additions. I always suggest you to go with this table, which is going to help you out in understanding. So when you add 1 bit, you get 128. When you add 2 bits, 122 192, because 128 plus 64, 3 bits if you add, it becomes 128 plus 64 plus 32, so like that. So probably I'd suggest you to refer this table. So instead of adding every time, even if you add, you get the same values. Okay, so remembering this table will save your time when you are doing this. So this is what we did. So we calculated this part, how many bits we require, and then we calculated how many bits required, how many converted, and how many total. And next thing, we calculated what will be the subnet mask, the third step. And the last thing, we need to write the range. So before we write the range, suppose if anyone asks you how many subnets we get. So let us find out one more thing, how many subnets we get. Subnets means how many small networks we get after dividing. Like you know that by default, a C class network supports 256 addresses, which starts from 0 to 255. So if you divide them into 16, 16, 16, 16, how many small networks we get? So I always suggest you to use this simple formula of 2 to the power of n value, 2 to the power of converted network bits. So converted means your extra network bits. You can see these are extra bits, whatever I got here, the 4 bits which I convert. So whatever the extra bits, just power them to get the value. So I converted 4 bits. So exactly I get 16 subnets, which means I get exactly 16 small networks if I divide a default C class example. Okay. So the last thing, we need to write the range. Writing the range is much more simple here. Let us start here. So finally writing the range. The range always written based on 2 to the power of h value. So in our calculation now, the h value is just 4 bits, because there are 28 network bits and 4 host bits. So the size of the network is 16. So multiples of 16, group of 16 addresses becomes one network. So if I take any C class example, so if I take 200.1.1, any C class, anyway the calculation remains the same, 200.1.1. So this 200.1.1 remains the same till the end, it will not change. 200.1.1 remains the same. Similar way on the right side also, the 200.1.1 remains the same. So writing the range, group of 16 addresses. So the first range starts from 0 and the next range starts on 16. Just you have to write multiples of 16 because the size of the network is 16. So 32 plus 16, 48, plus 16, 64, plus 16, 80, plus 16, 96, plus 16, I think it's 10112, 112. And if I do plus 16 I can say 128, plus 16 it becomes 144, plus 16 160, plus 16 176, plus 16 192, plus 16 208, plus 16 224, plus 16 240. So anyway, you get exactly 16 subnets because already we calculated here. If you remember, we did here already. Exactly, I get 16 subnets. So if you just count them, it is exactly 16 subnets. Okay, let's move on here. Fine, 16 subnets. So the range will be 0 to 15 will be one network, 16 to 31 will be one network, 32 to 47 is another network, 48 to 63 is another network, because next network starts on 64, means my network ends on 63. So next network 64 to 79 is one network, 80 to 95 is another network, 96 to 111 is another network, and 112 to 127 is another network, 128 to 143 is another network. So let's come down. 144 to 159 is another network, 160 to 175 another network. So 176 to 191 is another network, and 191 to 207 is another network, 208 to 223 is another network, 224 to 239 is another network, and finally it is 240 to 255. So anyway, not really required to write each and every range, because when we get into production networks we really don't need to write the range, but you should have a very good understanding on how the range comes. This is one of the little bit more complicated part. This is something which varies in each and every calculation, but most of the remaining calculation remains the same for every size of the network, but this is something which varies based on examples. So now we already learned that the first address will be the network ID and the last address is your broadcast ID. So we cannot use 0 address, we cannot use 15 because 0 is network ID, 15 is a broadcast ID. If I use the subnet mask of 255.255.255.240, that is what we got as per our calculations. So if I use this subnet mask, I cannot use 0, I cannot use 15 because they are network ID and the broadcast IDs. So the calculation, it's almost similar. The more you practice these examples with the variable requirements, the more you'll find it easier. Okay, that's the only way to master the subnetting calculations. Okay, so you just need to make sure that you really work on some more and more examples to have a better understanding and also clarify your doubts. Even you have some issues, like something goes wrong, you just make sure that you do it properly, step by step process. Okay, so this example again gives you the same idea. So again, this example is exactly giving you the same idea of what we did. So subnetting. So this is our second example in class C, right? So class C, we did one example, the basic example in the previous class, previous session. So it's the same example here. So now I think up to now, once you work on some 2 or 3 examples, so probably you can just hold on and you can practice some more examples before we get into the next part. Okay, so whatever the examples I discussed previously, you can just move on with some examples. Like you can take any C class example, you can take a requirement of 100 and you can take the requirement of 30, and some other example you can take a requirement of 10 and you can divide this examples. So once you do these 2-3 examples, probably you'll find it more easier in this step-by-step process.